October 19, 2017. A quiet afternoon at the Pan-STARRS Observatory in Hawaii. Astronomer Robert Warwick was reviewing telescope data when something strange appeared on his screen. At first, it looked like a glitch, a flicker. But then came the realization. This wasn't a normal asteroid. It wasn't a comet. It wasn't anything we'd ever seen. It was moving fast, 59,000 miles per hour on a path that made no sense. It had come from beyond our solar system, and it was leaving just as quickly. Humanity had just been visited by something from the stars, but what was it? A rogue rock? A chunk of nitrogen ice? Or an alien probe?
The object was officially named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. But it was more than poetic, it was accurate. From the start, Oumuamua baffled scientists. It was roughly the size of a football field, and its shape was weird. Some data suggested it was long and cigar-like, over 1,300 feet long. Others argued it was flat and pancake-shaped. Either way, it didn't match anything we'd cataloged. Even more disturbing, it had no tail. Typical comets release gas and dust when they approach the sun, but Oumuamua was silent. No trail, no emissions, no visible activity. Yet somehow, after passing the sun, it accelerated. It sped up without releasing gas, without any visible propulsion, almost as if something pushed.
Calculations showed that Oumuamua passed just 23 million miles from the sun, closer than Mercury. That's when it happened. Its velocity increased dramatically, from 59,000 to nearly 195,000 miles per hour. But how? No outgassing, no jets of vapor, no detectable force. The acceleration defied everything we knew about comet behavior. It was moving in a way that made some scientists suspect we weren't looking at a natural object at all. Was it an artifact? A probe? A ship? Harvard astronomer Avi Loeb thought so.
In 2021, Loeb and colleague Shmuel Bayali published a paper suggesting that Oumuamua could be an extraterrestrial light sail. This isn't science fiction. Light sails are real. Thin, ultralight structures pushed by sunlight or lasers capable of accelerating without fuel. Japan's Icaros probe used one in 2010. The physics is sound. Loeb proposed that if Oumuamua was only 0.3 to 0.9 millimeters thick, about the width of a human hair, it could explain the object's bizarre acceleration. And if it was a solar sail, it might have had other systems too. Scanners, transmitters, maybe even a navigational AI. But if it was a probe, who sent it? And why? Critics pushed back. Some suggested it was a chunk of nitrogen ice from a Pluto-like planet. Others blamed hydrogen gas jets. But none of those explanations fully accounted for all the data. Oumuamua had no dust, no tail, and it moved too precisely. The truth remained out of reach, because by the time we saw it, Oumuamua was already leaving.
Today, Oumuamua is more than 4.3 billion miles away and counting, invisible to all telescopes. But one group of engineers refused to give up. Enter Project Lyra. Founded just 11 days after Oumuamua's discovery, this initiative proposed the impossible: send a spacecraft after it. To do that, engineers would need to build a probe fast enough to catch an object moving through interstellar space. Not easy. They'd use gravity assists, slinging the probe around planets like Venus, Earth, and Jupiter. Or go even riskier, dive toward the sun, skimming just above its surface using the immense gravity and solar radiation for a final blistering push. Speeds up to 163,000 miles per hour could be achieved. But the heat would be brutal, over 1,400 degrees Celsius. Luckily, NASA's Parker Solar Probe already proved it could be done using carbon foam heat shields. If the LIBR probe launches between 2030 and 2033, it could intercept Oumuamua by the early 2050s, assuming it's still visible, assuming we can find it again.
While Oumuamua vanished into darkness, other strange objects remained closer to home. Beyond Neptune lies the Kuiper Belt, a frozen graveyard of ancient solar system relics. Some of these objects are as large as Pluto. Others are only a few kilometers across. But many defy explanation. Take Arakoth, a snowman-shaped body 4 billion miles away. It may hold clues to how planets form. Or Orion, a rapidly spinning object that should have torn itself apart, unless it's made of something stronger. Could these bodies hide alien technology? Most scientists say no, but curiosity lingers. Another candidate, 2002 UX-25, is less dense than water, meaning it could float, but it's over 400 miles wide. That kind of porosity shouldn't be possible. And then there's Quauquar. It's warmed up inexplicably over the last few million years. Some think it had cryovolcanoes. Others wonder, did something heat it? Still deeper lies Sedna, a blood-red world that takes 11,000 years to orbit the Sun. Its strange path may point to a hidden giant, Planet 9, or perhaps something stranger.
Here's a haunting thought. What if Oumuamua wasn't the first interstellar visitor? What if it was just the first we noticed? In 2029, the European Space Agency plans to launch Comet Interceptor, a spacecraft designed to lie in wait at a gravitational point in space, ready to intercept the next fast-moving object that comes from beyond. Next time, we might be ready. Next time, we might not miss our chance. Because when Oumuamua came and went, we didn't just miss an object, we missed a message.
To this day, we still don't know what Oumuamua really was. A rock? A sail? A probe? An accident of nature? Or a deliberate whisper from the stars? It came uninvited, left no answers, and disappeared before we could even ask the right questions. But perhaps the most important thing Oumuamua gave us was a reason to look deeper, to search the shadows of our solar system, to build the tools that might catch the next one, and to ask ourselves, if something truly alien ever visits again, will we even recognize it? If this left you questioning everything we know about our place in the universe, hit that subscribe button. The stars may be silent, but we're finally learning how to listen.